All right. Okay, so as I mentioned, there's a class page. The class page will contain slides for every class as well as the recording. So recordings will usually go up like the next morning or whatever. The class notes and links and things we discussed during class, I'll make sure I add again, usually the morning after. And then the most important thing for most of us here will be um, every week, or like I guess the week one of each section, there will be a list of films here. So these films will just sort of be everything you'll want to watch for that first week. I have started filling it out for later weeks as well. My recommendation would probably be to just wait because you'll probably forget films or you'll mix stuff up. But if you're have a weekend and you're like just burning through films, go for it. These are already linked as well, so I'll probably be putting them up like as every week as I walk through things. Like for example, today I added a new film like an hour before class started because I was just like, yep, we need one more. So we'll go through those. So each of these are linked to a Drive folder, so you can just download them from there. I'll share the folder directly as well, so if people just want to download them in bulk, they can do that too. You'll see most of these films range between like the 1930s and usually the 1980s. There will be a couple later ones as well, but for the most part, these will be a slightly shift toward older. I'm also trying to do my best to make sure that there's content warnings here because these are experimental films. One, there's a lot of nudity, and two, there's a lot of flickering. So if strobing or flickering is not your thing, I would definitely recommend avoiding those and or having someone watch them beforehand if they know you well enough to know that like, yeah, that's going to affect you or not. Within the nudity stuff, some of these are like hardcore. Like I would straight up not show fuses if it were made by a straight white guy. But because it's made by a woman, it's like slightly more interesting. But this one is very sexually explicit, so just beware of that. I'll try to make notes of those if possible. If you want to skip them, that's totally fine. Again, there's no like, I'm not going to quiz you on any of the films. So I still think they have value, but you should decide what you want to watch or what you don't want to. So that's I would assume the bodies one is probably going to be the most likely to contain nudity and other things. Yeah, so just be aware of that. I try to my best to make notes of that beforehand, just so no one's shocked or surprised. Yeah, and then let's see what else I was going to say. Uh, I will try to keep them each to like under 2 hours. That's gonna be hard when we hit the structuralist film stuff because those guys love to make really long films. But I will do my best. I would also say like I usually will list how long each film is, so you can know what you're getting yourself signed up for. Most of them are going to be fairly short, like 10 to 15 minutes at most. But there'll be a couple long ones here or there. So just maybe plan ahead or just keep that in mind. But again, I'm hoping that you could do it like, the Sunday night before class or like, whenever, that it's still sort of fairly doable and not like, here's 10 films that are going to take up a whole Sunday or a whole day to watch. Um, Last thing about watching videos is I don't think there's any wrong opinion on this. If you start watching one and you're like, I hate this, skip ahead a little bit further and see if it stays that way. And if you're just like, I hate this, I don't want to watch any more of it, turn it off. Like there's no point in wasting your time. What I would say is like if you do like things, think about why you like them. If you don't like them, think about why you don't like them. You know, so I'm gonna sort of like hold my tongue while like when I give you the list, and then like maybe as we're talking about them, I can provide additional context, or maybe after we talk about them, I'll provide additional context. That's not to be like, here's a gotcha, or to like make you feel bad that like, oh, you didn't know this was the first film that did this. Like, it's not about that. It's just to provide a little bit of additional feedback. But I think in a lot of cases, like you should like go into a film and just like see what you think about it. And I don't want to sort of guide you one way or another. So um, again, the list of films is there. I what I will say is I'm more or less like kind of putting them top to bottom what I think are like really important for this class versus like less important. So if you're only have an hour, maybe start with the top list or like the ones at the top and then work your way down and see how you feel about them. So um, yeah, so this will be the first list, and basically your homework for the rest of the week will be just to go through this and watch these and then maybe take notes or just think about like which ones you liked, which ones you didn't. And then next week, what I'd love is we'll just start the conversation with just like who wants to talk about what film, and then we can have a little discussion and we can sort of move around from there to each of them. So as I mentioned, this is my personal list based on here's a category of things I want to talk about. Here's some films I know. So these are not like necessarily like the canon of experimental film. They're just more or less things I'm interested in. If there's a film that you think is related to this that you think is really cool, and you have a link to it, please share it. There's no reason that like we don't need to watch more films or watch less films. This just happens to be a group of films that I have access to that I think are cool, and I think cover like a topic that we can sort of like think about together. So again, I will not be offended if you're like, hey, I much preferred this film to this film. It's totally fine. And let's see, what else did I? Oh, and then software for this class. So I would love if everyone could at least be on Slack. I know Slack is like Zoom and it's like kind of overwhelming, but I think it's helpful, especially if you know you're going to miss a week of discussion. I'll basically what I'll do is like maybe like tonight or tomorrow I'll start a thread of just like film feedback or film thoughts, and you can go ahead and add your thoughts there. And if we want to have a discussion asynchronously about some of them before class or after class, like that's totally fine. So I tend to use Slack. It's also a good place to ask questions. I am much better over Slack than I am over email. I'm very bad at email. You're welcome to email me, but please know you might get like a 2 or 3 day delay in response. Whereas if you Slack me, you'll usually get a response within 12 hours or less. So that's just what I prefer, but we'll work around what everyone else prefers. And then Colab, we'll do a Colab session in like 20 minutes. So we'll talk about that. There is a paid version, but I think for this class, if you will likely be fine with getting away with the free version. What the free version will be is it'll be slower for you, and you might run into some resolution limits, but for the most part, I think you'll be fine in this class. Whereas other classes, I do generally recommend you pay for a Colab. For this, I think you'll get away fine with the free, and we'll just sort of see how that goes. Okay, any questions about class structure or anything else? All right, I will take silence as a no. So I just want to do a quick sort of discussion about why I think experimental film and machine learning art have some really interesting overlaps. Um, One, I've always been a fan of experimental film. Like I think, I was definitely one that was like in college going to like our like film, like on campus things where they would show like art house films, some experimental stuff. I think, as well as when I would take motion graphics. So I have a design background, so I would take motion graphics classes, and sometimes we would be shown like John Whitney stuff. Um, sometimes we would get to see more experimental stuff, but it was often like more motion graphic based. So I've sort of always been interested in it, and I think as I've gotten more into making films and machine learning, I've gone back more to like what are experimental filmmakers from the modernist era doing, and like are there ways to apply similar thoughts to machine learning work? Um, so a couple of key things I think are really interesting. So one about experimental film is in a world where like films today are made by like thousands of people, experimental film for the longest time was really just like one person with a camera, maybe some actors. Very often, no like lighting or anything. Like they just sort of went out and shot stuff, or they're doing stuff direct on film. So I think it's an interesting challenge or like an interesting way to think about it in that like one person made this, meaning it's like a very pure point of view, and there's like an interesting way to sort of like unpack that, and all of us being sort of again isolated or doing our own work. I think there's some value to take from like one person's pure vision, and also like it's small enough that it feels achievable, right? Like we can't watch like a Marvel film today and be like, yeah, I could do that myself, like that's definitely not $1 billion production that thousands of people worked on. So I like that as like sort of it's a small encapsulated thing. Experimental film was a much more welcoming place for women and queer directors than mainstream film. A lot of films are going to, well, I shouldn't say a lot. We're going to watch some films that were made by queer directors, by female directors. I will say, as the art world was not very welcoming to people of color, this is still true for a lot of filmmaking of that era as well. In the cases where I can find films of that by like either black directors or Hispanic directors or other things, I'll do that. But it's definitely a challenge. So if you have links or you have interesting makers that you want to share who fall into these categories, please do. I would love more work to show from those categories and those directors if I can. I think maybe Michael mentioned this, but I think there's a really interesting part of like a lot of tech art is very much about the tech and less about the concept or about approaches to storytelling or just approaches to filmmaking. A lot of these filmmakers have very strong conceptual approaches, like especially when we get to the structuralists, it's like almost purely concept and process, which can almost make it painful to watch sometimes. But I think there's just some really interesting concepts that could be applied to machine learning as well. So I think there's some really, really cool work there. Lastly, and this is something that I've sort of been thinking a lot about, is that there's a whole group of filmmakers who work within found footage. And I think there's a really strong overlap between how we think about using film we find or clips of other filmmakers' work with how we use data sets in machine learning. I don't know how much we're going to go into this, but I think it's an interesting topic, and if people want to discuss it more, I'm happy to. But I think again, there's a material usage part of experimental film that has strong overlaps with machine learning around ethics and what are you allowed to use, what can't you use, how do you change it to make it yours, those sort of things. So I think maybe I'll add some found footage pieces maybe toward the end of the class, but I think there's some interesting stuff there to think about as well. And to sort of tie this to machine learning, like I've been doing machine learning about 3 or 4 years now. And when you start, I think like one of the things you're like, oh, I just want to make a new image that looks different from what I had trained on or whatever. And as I've gotten more and more involved in making images, I sort of think that like one of the powers of machine learning is actually creating multiple images or sequences of images. Um, Making one image or a couple images using these models is great, but probably a waste of, if you're doing your own training, a waste of training time. Um, the bang for your buck is like you're spending a lot of money to get one or two images out instead of spending a lot of money to produce, different types of things. So one of the things about the classes that I'm teaching over the past like year or so is really about like extending and extrapolating what you can do with a model or what you can do with machine learning tools in general. Um, and I think machine learning really excels at being able to like produce sequences of images, whether that's interpolations you might see through AttnGAN or other things that work with like essentially single images at scale. I think there's just a lot of nice overlap that machine learning is a thing that can be powered by, again, solo creators to do more work in less time without making it a purely efficiency thing. I think it's just like it allows you to feel like you have a whole studio of staff to work with you instead of sort of like being reliant on making your own things entirely by yourself. And I think, one of the core parts of experimental film, especially abstract experimental filmmaking, is that, when in the early days of cinema, as a lot of stuff moved from like basically recreating plays into recreating sort of narrative film, there was a whole group of people that were trying to do like narrative film. But there were other artists who saw the potential of filmmaking as a way to essentially make like paintings move. And I think that's a really fascinating category or a way to think about work that ties really strong into machine learning, right? Because a lot of machine learning is like put an image input and then have it like animated or turn into a 3D space or other things. So then again, this idea of like making paintings move, which was a really popular thing of like the teens through the 40s, is a thing that we can come back to and look at and sort of like, okay, what did those artists do, and does that relate to maybe what machine learning could do today, that sort of thing. So for example, I want to show this is a really early piece of Walter Ruttmann, one of like I think one of the early abstract filmmakers. So if you haven't seen this, I linked to the whole video here. I'm just going to show a minute or two just to sort of show like what I mean by making paintings move. So that's obviously much longer, and there's more there as well. But um, Rutman was a part of an early group of European artists who saw the potential of cinema as a way to make the paintings they were already trying to make move, sort of visually, spatially, actually move. So I believe the way that he made this is it was actually it's glass and there's a camera underneath it, and he was like painting like almost an oil paint on glass, and then he would wipe it away. So every frame he was literally painting. Um, and then I believe it was probably shot black and white. Then it was color toned after the fact. Um, but so many of these early artists were just like, here's my painting, which I already see moving in my mind, and I want to make it actually move on film and have people experience it. We'll cover some more of like these early folks. Like there's a lot of especially when we get to the visual music part, because a lot of these people were making instruments that would produce this as well. Um, so I think there's some really interesting stuff. I should mention Walter Ruttman, while supposedly being a pacifist, would later go work for the Nazis and make films for them. So maybe not the best person long term, but I think he did some really interesting work early on. And there's a bunch of these Lickspiel opuses. Many of them are on YouTube. A lot of the stuff you can find on YouTube, especially early stuff, because it's out of copyright, but it's usually very crappy quality, like very low res. So hopefully I've got some slightly better resolution versions here. But if you're interested in more, there's a lot more here to look at. But again, I just want to highlight like stuff we're doing today. Like a lot of people reach out to me and they say like, okay, I've got four images and I want to interpolate between them, which essentially means I want to make these images move, right? And I don't know how. And it's like we're still trying to solve this even today. And lastly, yeah, we'll take a break in 5 minutes. I'm just going to wrap up here a little bit. So lastly, I mentioned like there's a lot of really interesting conceptual overlaps between experimental film and either computational video, computational film, generative art, what do you want to call it. So the way I've sort of broken these out, or am thinking about these per each 2-week section, is abstracted bodies is like we'll see a lot of dance videos. It's the era of modern dance really sort of exploding on the scene, and people wanting to record those and find ways to manipulate those. Because these are like more private, we'll see a lot of people basically taking a camera into their bedroom for better or worse, and really like focusing on different parts of the body and really thinking about bodies. So I think you could think about it, maybe surveillance, pose tracking, where we'll definitely look at, how do we take a body and be able to begin to know using machine learning what parts of the body we're looking at. We get to visual music. There's a whole category of image, paintings, film covering synesthesia. So we'll definitely look at some filmmakers who believed they were doing is combining film and audio in the way that their brain processed it. We'll definitely look at different ways or different types of audio reactive material. So we'll try to like think about how we could apply that to machine learning as well. Cinepoems are really non-narrative. What are ways in which you can create almost like a poetic style using film? I think a very obvious way, and probably one of the hottest things in ML art today, is text to image, right? You can put in a poetic phrase and get out an image. Is it the image you expected? Is it the machine's generated image based on funny things or interesting topics there? So I think there's a lot to sort of think about and dwell on in that topic. And then lastly, when we get to structural, like the structuralists were really obsessed with sort of processes. I would say this is sort of what generative art is today, right? It's really like, what are the rules for making this thing, and how do I apply those rules? Structuralists were very much into rulemaking, but they would introduce things like chance. They would think a lot about sort of the material they were working with. So when we look at that, we'll think a lot about like sort of maybe how that applies or doesn't apply to machine learning. So as I mentioned, that's sort of it for the first section of class. So if you're already familiar with Colab and feel pretty comfortable using it, you feel free to drop once we take our break. Homework for next week is essentially just to like, if you're not familiar with Colab, to maybe get a little bit more familiar. I'll talk about that after our break, and then just to watch the playlist of films. So as I mentioned, they're just on this documented here on the page, and when you click on one of them, you should get a link to a Drive file that you can either download or watch directly in the browser. So as I mentioned, probably go top to bottom if you feel like you're going to be short on time. Otherwise, jump around and pick stuff. Another thing I should mention is throughout class, I'm probably going to try to just show one piece from an artist. So I won't like show you like 5 Mary Ellen Butte films. If you really like an artist, like please let me know. I probably have more from them, or definitely I recommend doing a Google search and seeing what you can find of their work. A lot of this stuff is often on out of print DVDs, or it's like on a site that is very expensive, like Criterion Collection, or like some other somewhat oddball streaming platform. Um, I'm happy to give people what I have if I have it. But yeah, please let me know if you're really interested in one of these artists. I would say almost all these artists were doing really interesting work and have more than one film, and I had to sort of pick what I thought was best for the category. Um, so yeah, please let me know if you want more of this, and I can find more for you. Any questions about experimental film, the class structure, any of the material here? All right, I promise next week there will be less of me talking at you, which I'm very excited about. So next week it'll be like we'll watch some films, then we'll just talk about them. So again, and I'll probably start a Slack thread. Probably tomorrow. I'll just like start a thread and be like, abstracted bodies films. Let me know what you thought. And if you have thoughts you want to start jotting down, you're more than welcome to. Otherwise, you can save them for next week, and we'll go through them together, and we'll just sort of talk. And like I said, if we talk for all 2 hours, that'd be awesome. But I'm sort of scheduling that we'll talk for about an hour together, and then we'll jump into some work. But if not, if we fill it up, that's totally fine with me. Cool. All right, so why don't let's do a 10-minute break. So we'll come back at 8:45. For those of you who do feel really comfortable with Colab, um, I'll see you next week. Or you can hang out. It's up to you. But yeah, we'll just come back and we'll go lightly through what Colab is and why we need to use it. And then I'll do a couple quick demos for folks. All right. See everyone in 10 minutes. All right, so the main tool we're going to be using in class when we're actually generating stuff using machine learning is a tool called Colab. So I'll just talk a little bit about what it is, and then we'll do a demo. I'll say for this class, unless you want to do extracurricular activities, I'll mostly walk you through the notebooks you need to use. So hopefully like a tutorial and just the recording, you can just watch the recording over and over again and sort of follow the steps I do. So hopefully it won't be too scary. I do admit Colab is kind of a annoying tool if you're not used to it, but it's kind of powerful and kind of the only thing available for us at a reasonable cost. So yeah, so hopefully we can walk through it. And I will say like if you feel like you're struggling with Colab, like please try to show up to one of the co-working sessions, and I'm happy to walk through it a little bit more with you. So what is Colab? So Colab is a tool from Google. Just to warn everybody, it is a Google tool, evil corporation, whatever. It is unfortunately the most cost-beneficial, cost-effective tool for doing machine learning today. So it's kind of our best shot. If you are very anti-Google and you want to use something else, let me know, and I can probably like link you to some things. But it's definitely the most cost-effective by a long ways. So it's essentially Linux-based computers. So when you open up a Colab notebook, they're what's referred to as notebooks. When you open one, it connects to a Linux GPU or a Linux computer with a very high-powered GPU. And the GPU is really what we need for machine learning because if you've ever done any 3D rendering or After Effects or anything like that, GPUs help generate images and video renders much faster. And the same is true for machine learning. So we kind of need those GPUs. And I'll talk a little bit about that more in a minute. It's based on a thing called Jupyter Notebooks. So if anyone says like, "Oh, are you taking a machine learning class?" and they're like, "What are you using?" You can say we're using Colab. Most people know what Colab is today. If they don't, then you can just say like it's a Jupyter Notebook kind of environment. It is free, which for this class, I think using the free version is fine. There are paid versions, which I'll talk about in just a minute, but I think for us, we'll be fine with the free. What'll happen is like your machine will be slow. It might be slow to render stuff, but again, it's kind of the most cost-effective version possible. So as I mentioned, it's free. The really nice thing I like about Colab is it is essentially a quote unquote notebook, which means there are code cells you can run and there are text cells you can run. And what I recommend for everyone is that the first thing you do when you get a notebook from me is make a copy of it, and then you can add your own notes, right? So if you need help, like be like, okay, remember to do this or remember to edit this, like please just add that to your notebook, and we'll look at how to do that in a minute. But it helps so that you can create a lot of notes for yourself and run code directly from it. It'll save us a lot of time. All the dependencies are included. If you know what that means, it means it come pre-built with PyTorch and other things. It's very nice. Also, they're web URLs, so I can share a file with you and you can just run it. Whereas other things you have to like get involved with Git and other things. It's very annoying. So this is just a very like, it's cost effective and it's pretty user friendly. I say that with like user friendly in quotes because it isn't the most user friendly thing, but it is more user friendly than the other options. Downsides of Colab is that there are time limits. We probably won't really run into that in this class. Maybe if we generate really long videos, we will, but for the most part, we'll be fine. This is really a problem if we're doing training, but we'll only be using pre-trained models in this class. I know some folks do know how to train their own models, and you're welcome to use your own training models, but for this class, we won't be doing that. There are some GPU, CPU limits, mostly around whether you're willing to pay them or not, but we probably won't really worry about that too much for this class. And as I mentioned, this is a Google product, so if you are very privacy aware, you might want to create your own little like Google account just for Colab and just keep it at that and keep it sort of siloed off from the rest of the stuff. There are pro versions of Colab. I won't go into this too much because again, I really don't think we need it, but if you do feel like I could use to like get this to run a little bit faster, there's a $10 a month plan, which is only available in certain countries with an asterisk, in that if you figure out a US zip code and have a US like credit card that'll work through most of their payment processes is fine. You'll get a longer runtime, which again, we won't worry about in this class, but maybe if you do want to produce a really long video will be helpful. And you have a higher chance of getting a good GPU, which means stuff will just run faster. There's also a brand new $50 a month plan that gets you really good GPUs, longer runtimes, that sort of thing. I would say unless you really are going to use this day in and day out, Colab Pro Plus is too much for you. Look at the Pro plan. $10 a month is a steal, even at $10 a month. So if you have the money and you want something a little bit faster, it's a good deal. What I would say is probably like spend the first couple weeks in this class running stuff and see how you feel. And if you feel like you need to upgrade, it's very easy to upgrade from there. So what exactly is Colab? So if you're not a programmer, you might not know exactly what each of these things is, but I'll tell you that it's helpful that they all are combined into one. Colab is a terminal interface, which is, maybe what you've seen like the hackers in movies use. This allows you to run what's called command line programs. So it combines that with a code editor, which is like where you can actually write code, as well as, place-to-place notes. For everything we're going to look at in this class, these two things will be covered for you. You won't need to do any writing yourself unless you want to. All of the code and commands will be pre-written for you, and I'll basically say like edit something on this line or upload this image, and that's all you'll need to worry about. But I do recommend taking part in the notes and like adding notes for yourself to remember what you're supposed to do here or there. The last thing, and which is the really important thing, is it adds a GPU for us. The GPUs they give us access to, if you were to try to buy one brand new, are usually around $10,000 or more. So $10 a month sounds like a steal when you compare that, and it is. So that's really why, again, Google is Google, and they can do that stuff for a lot cheaper than we can. So that's why, if I were to recommend other tools for you, you would be spending hundreds of dollars a month to do what we're going to do for essentially free. So that's why I kind of like say like this is the best tool for us and why we're going to use it. I'm going to skip through this stuff because it's not really important for this class, but just know that like there are code cells you can write directly in them in either Python or in Bash, and the way that you structure stuff matters. If you're really interested in this, let's talk about it in a co-working session. If you have some programming background but this is your first time using Colab, I'd be happy to talk about this more. For this class, probably not important, and I think we should just get to the demos so we can see how it works in action for most folks. The one thing I will mention is that the notebooks we look at, each one will work slightly differently because some I'll write, someone else will write, and some third person will write, which I admit can be a little confusing. But again, my hope is that we'll record every tutorial. You'll get those recordings. And what I would say is, when you load up the notebook to start do your own work, load up that tutorial alongside it in YouTube or whatever, and just follow it step by step for that first time. You're welcome to, again, follow along with me in class. I might move a little bit quicker just because I will likely have a faster GPU. But we can walk through things together depending on how much time we have. But I do recommend using the recordings as well as coming to co-working sessions if you do get stuck anywhere. So often you'll see notebooks that have sort of these GUI interfaces, these very like sort of kludgy, enter some text, enter a number, click a checkbox. This is what you'll commonly see with a lot of notebooks. My notebooks will be more written like this, which whether it's easier or harder to read, I couldn't really tell you. Maybe you can, where you will set variables in like the code cell. This is the same as this. It's just whether it's like in this gray box or in this white box. But again, I'll walk you through what you need to edit for what you must edit and what you might want to edit in every notebook. So we'll go through it one by one and go through each step. So don't worry too much just yet. Usually what I find is people get very frustrated with Colab for the first week or two. And then by the end of the class, you're like, I can't use anything else. Like this is just, it's sort of ingrained in the way you work. And quite honestly, like if you've ever used Runway, I usually teach Runway classes and people very quickly hit walls where Runway doesn't do what it wants to do. It is especially bad for video. Even though they have a video tool, the machine learning part isn't really connected to video tools, and it makes working with video or animation really hard. This will be much easier in Colab. So if you struggle, I promise you everyone struggles initially, and after a little bit of time, you'll sort of get more comfortable with it and get used to it. So let's actually take a look at a couple notebooks. So I've already loaded these up, but I'll drop the links for them in our chat for everyone. Again, you're welcome to follow along, or you can just watch the recording at a later date. It's sort of whatever you feel comfortable with. So often links will either open directly in Colab or they'll open in a file like in a GitHub URL. This is not a GitHub class. Don't worry about anything about GitHub. The big thing to remember for this is that there's going to be a button here that says open in Colab. Just click on that. Ignore everything else. Just click on the open in Colab button. When you do that, it is going to open in colab.research.google.com. If you do not have a Google account, you do need a Google account in order to use Colab. So just go ahead and set one up. Just set up like a small little dummy account. It's totally fine to do that. I have 4 or 5 Google accounts, so you can switch between them fairly easily. It's just like a Google Doc. I assume most of us have a Google account at some point. Whether we use it frequently or not is a different question. So I've already got these open because I had to run a couple additional things for myself because I am on the Colab Pro Plus plan, which means I get really good GPUs, but they're so new that some of the software doesn't work yet, so I have to run some additional stuff to get out of them. If you are going to buy Colab Pro Plus, which is the $50 a month plan, just let me know because I can make sure that I cover any additional material you might need because you will generally get a really fast GPU with that. So this is what the Colab interface looks like. It looks very much like a Google Doc, except there's some slight differences. So usually the first thing you're going to want to do when you come to, actually I should just open this again. Let me do this. So when you open a notebook, the first thing that you'll see is, okay, this will usually say connect. Because I'm already connected to this notebook, it's going to do a funky thing. But if you have yours open, it probably says connect over here. So generally what I recommend, the first thing you do is just hit connect. That way you're just connected to the server. What that does is it spins up that Linux GPU behind the scenes. Cool, so Steven's on Colab Pro. If you're not on Pro Plus, I think you probably won't get A100s, but we'll see, and we'll just sort of walk through it. So click connect. That way, once you click connect after a couple of seconds, you should see something that looks like this, right? There's a green check button, RAM, and disk. So I'm just going to close this and move over to the notebook. So once you have that open, you're now connected to the computer. And when I said you get 10 hours of continuous runtime, what that means is that as long as you're doing stuff in the notebook, this will stay open. But let's say someone rings the doorbell, you go answer it, and then you forget about this notebook. After about 20 minutes or 30 minutes, it will close, meaning it will close your session. The thing to be aware of with that is that you might lose your work. And I'll talk about like the file interface and that sort of thing. So one key is just to make sure that you remember that your notebook is running in the background, check on it every once in a while. There's some tricks that we can talk about throughout class as we go through these notebooks in a little bit more detail about how to keep things open or how to save files so if it does close, you don't lose your work, that sort of thing. But just know that it will shut down either usually after about 15 to 20 minutes to 30 minutes of non-use, or when you hit that time limit. So again, if you are on the free Colab, I think after 8 to 10 hours, it'll shut off. So even if you're running stuff continuously, it'll shut off after 8 to 10 hours and you will lose your work. So if you're creating a really long video, we'll talk about this as we get later into the class, but you'll want to save that stuff directly to your Google Drive account in order to save your work. I'll cover that in just a minute because Google Drive and Google Colab play very nicely together, and I would recommend. I think most Google accounts come with a free like 10 gigabytes of space or something more than that, and that'll probably be enough for this class. But there are paid plans of Google Drive as well if you want to spend more money. It's sort of up to you. Okay, so that just covers sort of the basics of how these things work. As I mentioned, usually what I recommend for folks is the first thing you probably want to do, actually before you hit connect, now that I think about it, is you're going to want to save a copy for yourself. So we'll go to File, and then we'll go to Save a Copy in Drive. This assumes you all have drives, which you probably will. If you have a Google account, you have some sort of free drive space, so that's fine. So let's hit Save a Copy in Drive. And once you do that, then you can make edits anywhere you want to. So you can sort of rename it. It'll just say copy of. So you go ahead and make edits, and I'll show you how to do that in just a minute. Let's talk a little bit about the interface here. So along the top are just a bunch of things you'll use. To be quite honest, I don't often use these. The one that you might look at, and we'll cover this later at a later date, is maybe change runtime type. But I think most of the notebooks I'll give you, you won't have to worry about that. So I'm just going to give you the bare bones sort of Colab demo, and then as we hit more levels, we'll we'll level up ourselves as we go through this. Along the left here are 4 very important buttons, or like 2 very important ones and two kind of cool ones. The first is the table of contents. So just like Google Drive, these notebooks, have a bunch of headlines. If you structure your headlines correctly, you will get sort of an outline of how the notebook works. This is helpful because some of these notebooks do get long, and you might, after like getting kind of comfortable with them, you might learn that you want to jump around a little bit. So this allows you to jump between areas just by clicking through each of these. Search allows you to search sort of if you're looking for a particular line in here and you want to find it, you can do that. Code snippets, I probably won't cover code snippets in this class because we won't need them. If you're a programmer, I definitely recommend looking into code snippets. I have some videos on how to use them, that sort of thing. So if you are interested, I'm happy to share that. And the most important thing, this is like the most important part of most of Colab, I would say, besides the notebook section itself, is the file browser. So this is where you will upload files. You can either click the upload button here to upload a file, or you can drag a file directly into this sidebar. So this works just like a file browser on a Mac or Windows. There are folders. Inside folders are files. If you choose to connect to Google Drive, what will happen is you'll get Google Drive will connect here, and then you'll be able to look inside of your Google Drive like it's a file on your computer. It's actually a very nice interface, very seamless, very helpful. So this is the most important thing to know about. As we go through demos, we'll learn like, okay, this is how, if you upload a file, here's how you reference the folder path, that sort of thing. So we'll cover that as we get further along into these demos. One note is if you press this icon instead of this icon, this will take you to the root level of your folder, which is like sort of, I'm just going to do it, but you don't have to. Please don't actually. This will take you into the root of the Linux machine, which is the guts of all of a computer. Just know that you can't really get back to where you were, but the folder that we usually open into is what's called content. So if you open the content folder, that's where all your stuff is. So every once in a while, someone will hit that button and be like, I have no idea how to get back to where I was. And just know most of the notebook takes part in the content folder. So just be aware of that. Everything you'll want to upload it directly into the content folder then if you do end up in this interface. This also refreshes your file browser. We'll take a look at that in just a minute. So this is like basically, I usually switch between the table of contents and the folder. Those are the two most important parts. Now on to the actual most important part, which is the cell environment. So as I mentioned, Colab has a concept of text cells and code cells. Code cells will have a black background, and when you hover on them or click into them, have a play button next to them. I'll cover that in a minute. Text cells look like text. And if you double click into it, it opens into an interface that looks like this. And this is what's called Markdown. If you don't know Markdown, don't worry about it. Basically, this allows you to add notes. Like let's say this is a notebook from the week 1 experimental film class. And there are, you can bold stuff. So you just select the text and hit bold. You can add links. You can add a bunch of other WYSIWYG things here as well. So when you are done editing a notebook, let's see, oops, there we go. This will be updated over here. When you're done with a cell, click inside of it and hit Shift Return, and that will sort of save it. So there's sort of like the editing interface, which is this, and then sort of the saved version, which is this. Here again, if you have your copy, this will like basically save all your work as it sort of auto saves. If you open one of these GitHub links or another link, it likely won't save any changes you make, which is why I recommend making a copy, and then it'll save all your changes as you go through it. All right, so that covers text cells. To add a new text cell, there's a couple ways to do it. One is you can press the plus text or the plus code button here. Another is if you hover between these cells, you'll see as you hover, you get plus code or plus text. And if you hit plus text, it'll give you a new text cell. And if you hit plus code, you'll get a new code cell. So pretty straightforward there. All right, so let's start to run some code cells. So usually the first thing you will see at the top of pretty much any notebook I give you is this command, which is ampersand, or sorry, not ampersand, exclamation point NVIDIA-SMI. Running this cell will tell you what kind of GPU you have. So to run a cell, there's two things you can do. One is you can hit the play button, or you can click into the cell and then hit Shift Return. I will often do Shift Return because it's just faster. Programmers are notorious for like very small efficiencies, that sort of thing. Having to scroll to a play button is slow. So if you're not sure how I ran a notebook, it often means, or ran a cell, it often means I hit just Shift Return and you didn't see it. So Shift Return runs a cell. Most cells will run very quickly. Others will take a little bit of time. We'll talk about that in a minute. And when you run it, the thing to look for is this sort of block here. So many of you will either see, I'm going to guess you're either going to see a K80, a T4, or a P100. Does anyone see anything but that? Yep, K80. Anyone see anything else besides a K80?
I see a Tesla.
Okay. Is it a Tesla K80, T4? What's after Tesla?
P100.
Cool, P100. Yep. Okay, cool. So this is, if you pay for Colab, you are more likely to get a P100. Now it's not to say that like if you get a free, you might be given a P100. This whole thing operates on some sort of like, who knows algorithm, that as these things get busier throughout the day, you will get a worse GPU depending on how much you're paying them, right? Or not paying them. K80s are the worst, which means they'll be the slowest. It's still fine if you get one. For a lot of what we're going to do here is going to be fine. T4 is the next slowest. Then it goes P100, V100, and A100. None of that is in alphabetical order. It is very confusing. For most cases, for these things, we're going to be fine. So K80, T4, P100, V100, A100. I assume most of you will not get an A100 unless you're paying $50 a month. That's what I get, but I do pay them a lot. So this is just helpful to know. Sometimes if you're getting error message, I might ask you what GPU you got. This is what you'll want to respond with, like the K80, T4, whatever. Especially if we're over Slack, I might just be like, hey, what GPU did you get assigned? Because the K80s are slow and they also tend to be smaller. So another thing you can look at here is this number. My guess is the K80 is something like 11 something or 12 something. Is that right? Yeah. So this is VRAM. So this is how much VRAM you have. So you'll see an A4, sorry, an A100 has 40 gigabytes of VRAM. That's a lot. That is very, very large. The K80 is 11 or 12. I believe the T4 is 12, and the P100 and the V100 are 16. This will limit resolution in most cases, and sometimes memory issues. So obviously getting an A100 means you can do higher res video, but with diminishing returns, it's not worth it. I wouldn't say it's not worth the $50 if all you care about is resolution. We'll talk about this maybe more as we get into other notebooks, but just know that these are the two numbers you want to look at. Sometimes you might see me with this. This, all it does is it tells you the GPU. So either of these work. It just depends on how much you have to scan the interface to understand what you're getting. So either of those will work. Because most of you don't have the A100, you don't have to worry about this. If you get an A100, you have to install the right package for a lot of this stuff to run. So just be aware of that. Okay, once we've sort of figured out what GPU we have, for us, most GPUs will be fine. One note is if you get an error message that says something like can't find NVIDIA-SMI, let me know about that. That just means that we have to turn the notebook into a GPU notebook. Very easy. Most of us won't face that, but if you do, let me know. We can work on that. Okay, so now what we have to do is we just have to start installing software. Most of these things give us the base stuff that we need, but then we need to install some additional tools. So we're going to run, this notebook's called AttnGAN. It is a very, it's a couple of years old now, but it does text to image. So it'll produce images from text, which we might look at more later in this class, but I just want to show this one as a sort of starting point. So the first thing we're going to do is we're going to install some code from GitHub. All you're going to need to do is click in the cell and hit Shift Return. That took all of 30 seconds. You might not see any changes over here. Often what happens is changes don't update in the sidebar as quickly as you would expect. So what you do is you come over here and hit refresh, and now there's a folder in here called AttnGAN. This just contains all the code for our model. That's pretty much it. So in a lot of cases, what I will try to do in my notebooks, or what I'll do especially for this class, is I'll try to document if you need to edit anything above these cells. So I might just say so I might just do that. Don't worry about editing anything. Next, we need to install some model and data files. This one doesn't work, so we're actually going to skip this one. AttnGAN happens to ship with two different models. One is a bird model, meaning you can give it very clearly defined birds, and it should produce a good bird image. The one we're going to run is what's called COCO. COCO stands for something something object. This is a bunch of object generators. Again, if this is new to you, totally fine. We're going to cover more of this way more in depth when we get into later sessions. Just for now, all you need to know is I need to run this cell. So you can either come over here and press play, or you can click in and hit Shift Return. And this one's going to take a little bit longer to run because it's going to install a bunch of files, very large files, actually, probably a gigabyte worth of files, if not longer. So below here, below the cell, you'll see a bunch of stuff get spit out. And unless we see something like error or warning, we don't really need to worry about it. This is just the console. It's helpful for me to see. So sometimes if something doesn't work right, I might ask you to copy and paste this, which means you just come here, copy, and I might ask you to paste it in Slack or send it to me over chat. 9 times out of 10, we're not going to need to worry about this. So here again, mine ran very quickly. Yours might take a little bit longer because you might be on a slower machine, whatever. But at the very end, we should see something that says /content/AttnGAN/code. And all that means is that we've moved into a folder that is this folder. So we're in content, AttnGAN code. Okay, so the next step is we're going to run this cell. Don't worry about what this does. It just edits some things that we can't edit until we download all the code we need to do. So in this next cell, which allows us to write some, overwrite some files, we're just going to run this cell. And now we get to the fun part. So this is the part where we can actually make some edits. So in this cell here, we're going to create some captions. So by captions, essentially think about you're reverse engineering a caption into an image. So provide a caption here of an image you want to produce. So I'm just going to edit one of these. So let's say instead of a yellow car, we want a blue car. One note is this particular model, for every caption, for every image you want to produce, put the caption on a new line. So we can also do one like, let's say, oh, this was one of my students did recently that I thought was actually really good. Okay. So just add these, basically rewrite one of these captions or add one, whatever you have. That's okay. Yeah. So Scully mentioned that she just got a prompt that was like, change to a standard runtime. You're not running it using a GPU. We're going through this notebook a little bit slowly. Basically, like Colab gets mad at you if you're asking for a GPU notebook and don't run it. As soon as we run this cell, this one down here, we'll be using the GPU and it'll stop bugging us. Sometimes it just is a little like annoying and slow. Cool. Yep. Okay. So now that you've edited or added a caption here, we need to save this. So think about like until this cell has been run, nothing has been saved. Like essentially open in this file, but we need to save it to the computer. So when you hit Shift Return or the play button, what we're going to do is we're going to write this to a file. And if you're interested, this says write file, and then it gives you a path. And if we actually follow this path, so we go content, AttnGAN, data, Coco, example captions.txt, and if we double click on this, you'll see that my captions have been saved directly to this file. So really all we're doing in this cell is writing a file. It just happens to be called example captions.txt. Has everyone gotten that far? Cool. Okay. So now that we've saved our caption, we're ready to generate images. So this is the command that actually does all the magic for us. It's because all the code is sort of hidden behind the scenes. This runs a script called main.py, and then we're passing in an argument, which basically just says like, hey, we want to use the Coco model, which is all we have all the data for, and then we want to use these captions to generate images from it. So this will say, and we're using Python here, so we're going to say like, use Python to run this script using these variables or these arguments. So once we run it, it'll take a couple seconds and we'll get some images generated, and I'll show you where to find those. So go ahead and press run. And what you'll see here is you get a bunch of stuff spit out, which you don't need to worry about. If we do need to worry about this, we'll talk about it in a later class. This is again just saying like, here's what I saw as the configuration, and it seems to have run. And sometimes I notice that this happens where stuff gets like emptied, but there's actually stuff in it. So if you just click into the console and sort of like move your cursor over it, it reloads. You will see there's a couple things here. You'll see there's some warning messages. Warning messages are okay. Warning messages mean that in the future something might break, but today it's not. If you got to the end line and it said total time for training, and then it spit out a number, that means you're good to go. That means generate images. So what this is saying is the time it took to actually generate those images is this amount of time. So for me, it was 12 seconds. For y'all, it might be a little bit slower. Yeah, 47 seconds, so it's not awful. Yeah, so I mean, the K80s are still quite nice for single images. When we get to video and you need to start producing many, many images, it'll slow down a lot. But for this particular model, it's very fast. So the way to find your images are go back over to your file browser. And remember, you're probably in content, so you probably don't see this folder. But what you do see is in AttnGAN, you see a thing called models. And if you click on the twirly for models, and then the twirly for Coco AttnGAN 2, inside of there is a thing called example captions. When you open that folder, you'll see inside this folder are all of your captions with G0, G1, G2, G01, G1, G2. What you want to look at are the G2 files. So there's a decent image browser directly in Colab. So if you just double click on a file, you'll see here is my blue car on a road. And if I double click on red dog in the park, you'll see here is my red dog in the park. And if I double click may the force be with you, there is something that has a Star Wars-ish look to it. So this is a model that is 3 or 4 years old now. I'm sure many of you have seen the new stuff called Clip or Clip plus VQGAN or Clip plus something else. Um, that is the newest version, and if you've seen any of that artwork on Twitter or on Instagram or other places, you'll know you get much, much better results. The downside is that those notebooks are a little bit more complicated and a little bit slower. So I just want to do this demo because it's fast. If you're interested in just sort of getting your feet wet and to play with another notebook, I do have another Clip notebook here, which maybe we'll go through in like a co-working session or something. This one's a slightly different because this one has a lot of the same commands, but you'll see here there's some different options to pick from. And it's like you sort of have to pick things and you might be confused about what you're picking. What my general recommendation is for folks is start with all the defaults. So just run each cell sequentially one at a time, and you will sort of get results that way. And then once you know the notebook works for you or you like understand that nothing broke and you weren't confused by it, then you might want to come back in and read some of the stuff that they document to be able to sort of go through it one by one. So I won't go through this notebook tonight because we only have 10 minutes left in class. But maybe if folks are interested in a co-working session on Sunday or next Tuesday, if you'll want me to go through additional Colab notebooks, there are more available to you. I will also say that if you are still feeling uncomfortable about Colab, one, we're going to go through a lot more of these in class, so don't feel like it's you have to get it today. On my YouTube channel, there is a whole class devoted to Colab. It is Make ML Art with Google Colab. This is 4 weeks of classes plus some other materials. So if you want to go through that and learn more about Colab, you're more than welcome to have it. Oh yeah, so Doug, so this is in the slides, but I'll drop it here as well in the chat.
Great, thank you.
Yeah, no worries. Yeah, so again, don't feel like you need to learn Colab between now and next week because the whole point of this class is we're going to go through these notebooks one by one together. But if you are interested in just learning more, there's a lot more here available to you. Quite often I will, if you're new to my classes, like I will quite often link you to YouTube videos of me having already recorded these things, not because I want to get rid of you and not answer your question, but because often I have more in-depth answers on YouTube than I could in person. So it's not me shooing you away if I give you a link to a video. It's just me saying like, here's the most documentation I have on a thing, or here's something that is not like me after a long day of work with shoddy answers. So that's just so you're aware, that's usually how I will direct people to things. And also, like, I've now taught many classes on different topics, so we can sort of go deep into areas depending on what people are interested in. Oh, one more note about Colab before we wrap it up for the day. If you want to download these images and like share them to Twitter or Instagram or whatever, the easiest way is to just control click on the file, or I guess right click on the file. Yeah, right click on the file. How did I do that? I don't even know how that became gray. But anyway, go back to models, Cocoa Attention GAN 2, example captions. If you right click on a file or if you hover over the little 3 ellipses over here, you can go download. That'll just download the file. When we get into more complex stuff in class, the other thing we could do is we could zip up this folder into a zip file and download the zip file the same way. And then open up the zip file on our Mac or Windows. But for this, it's probably pretty easy just to download each file individually. Another thing we might do, which we didn't really do in this, but there is a way to connect to your Google Drive account. Let me show you that real quick. I want Drive. So if you see a code cell that looks like this, which just says from Google Colab import Drive, and then it says mount Drive, the way to do Drive mounting here is to run this cell, and you'll get a command in the console that says go to this URL in a browser, and you'll pick the Google account that you want to connect your Drive to. So we'll just go to my personal account. It'll say sign in. You're already signed in, so I don't really know what this is doing, but basically it says approve. You're just basically approving that like these two pieces of software connect to each other. You'll get this code, so you can just copy this code, and then you come back to your notebook and you paste the code in and hit return. And after a little bit of time spinning up, it'll say mounted at /content/drive. So that means inside of your drive, your content folder, which for many of you will be the top level, inside of there will be a drive folder. And inside of here will be all of your drive files. So for me, I have thousands upon thousands, probably millions of drive files. So this can get a little hairy to try to figure out where I'm looking for in here. But this is really nice because then you can reference anything you upload to Drive just like it's a regular file. It's a very nice interface, allows us to do some cool stuff in the future. But if you just want to save your images directly to Drive, another really easy thing you can do is you can just drag your image from here, just drag it into my Drive, and that will upload the file there. So see how that file disappeared, and now it's going to be in my Drive account. So you can download the file or you can drag it into Drive. Either of those work. And if you know command line functions like move or copy, you can also use those here and just copy directly to those paths, and it works just kind of magically because clearly it hasn't moved all 2 terabytes of my files over here. So that's a really basic intro to Colab. Again, next week, we'll start looking at Colab and we'll walk through sort of the exact same process. Again, for this class, pretty much I would say 90% of what you're going to need to do for a notebook is just run cells in order. And I'll highlight where you need to make edits, whether it's like adding a caption or uploading an audio file or doing some other things. So we'll connect all that stuff fairly easily. We'll probably, not next week, but the week after, probably do a little bit of P5 stuff as well. So again, I'll have a pre-built file for you to use. I don't want this to be a coding class for anyone, so it's sort of like what I imagine we'll do for a lot of this stuff is I'll have really like default style notebooks and files for people to use. And then we can use co-working sessions if you are like, I'm not really the best programmer and I want to edit this thing to do this. We can talk about how to do that. And I can help edit files and edit code as we go through it. And some of you I know are probably much more familiar with that stuff than even I am. So please feel free to sort of like have fun and explore the bounds of what you got once we like get you set up with sort of like getting some files and videos and JSON files and those sort of things to you. All right, so that's it for this week. So one note, I just realized during the break, so homework is obviously just to watch those videos. Like that's the #1 priority for everything we're going to do for next week. But I wanted to mention one additional thing you might want to do for next week is to find a short video clip of a single person doing something in space. It doesn't have to be on a like masked out background, but I would recommend one person rather than a group of people or 2 or 3 people. The tool we're probably going to run starting next week is a thing called OpenPose. And just for basics, it works best with a single person. It gets kind of complicated when you add more people into it. So you might just want to find a video, either it's something on YouTube, maybe it's someone dancing, maybe it's someone just walking. But it can be full body, or it can be like above the torso, or it can just be like hands and face. Like it's sort of open-ended. Maybe you want to grab a couple videos and just sort of see what works best. But I would say just start with like pretty short clips. So even if it's 10, 15 seconds, have that, because then we can play with those next week. I'll make a note in the homework as well as make a note in our Slack channel to find those. You can probably find one fairly quickly over your break if you forget for next week. But yeah, just the main thing is to watch the films and sort of like write down some feedback you have on it. Yeah. Any questions before we wrap up for the night? I will make a note, or I will I will ask if people want to do co-working sessions this week. I imagine because we're just really getting started that probably people won't. But if you do want to, just like, again, I'll drop a note in the Slack channel, usually the day before the morning of. And if people are interested in chatting, we can chat. Again, it might be a good time to just be like, oh, like I like these videos. Have you seen this one? Or, what do you think about this video? That sort of thing. We'll save most of the discussion for next week. But if you have quick questions, or if you are interested in, what are we going to learn, or like, will we be learning this thing? Either drop those notes in the Slack channel, or come to a co-working session. We can talk about it. Those co-working sessions are fairly loose. It's like sort of first come, first serve. Obviously, if 10 people show up, I will try to keep us moving through everyone really relatively quickly. But a lot of times it's 2 or 3 people show up, and then it's like we got a lot of time to dig into your project or like whatever you're working on. So I definitely highly recommend them, because it is sort of like a benefit of this class versus just getting the videos later. All right. Well, with that, I think we'll wrap up for the night. So again, I hope I'll see everyone on Slack over the next couple days. And then we will catch up again next week, and hopefully I will be doing a lot less talking and we can discuss some films. Yeah, so I'm really looking forward to it. So I'll see you all next week.
Thanks, Derek.
Thanks,
See you all next
Derek.
week.
Thank you.
Nice to meet
Awesome.
you.
Bye, everybody.
See y'all later. Bye.
Bye.
Thanks, Derek.